scale startups in scaling stage. So not incubation, they must be in scaling stage to help them to scale.
What is scaling stage?
Scaling stage, they must have a product, they must start selling, and then they start to realize that to grow fast enough is not easy. Okay? Then
I know that.
Exactly. To start a startup, you can do it with a few alone or with a team. But to scale a startup, you need, I would say, a village or a town or a city. Okay? I assume that some of you that have enough experience with startups and scale-ups, you understand that. Okay? So tonight we will try to explain what we have learned, and each of us with different experiences. Angelo is more in the operations field, productization, design. I'm more on the business side, marketing and innovation. And I would like also to introduce one of our partners from Singapore, Yusek, there. Thanks for joining us tonight. So, you can ask questions whenever you want. I will start with this picture. 1900 starts the manufacturing period of the, let's say, 20th and 21st century era. By the 1960s, we entered the distribution stage. What does it mean? Where the power was. Between 1900 and 1960, the power was with manufacturing. 1960, the power moved to distribution. 1990, the power moved to the information technology. And now we are in the period where the customer has the power, not the companies. And that means whatever you do, you need to think about that. And the next stage will be the IoT, AI, blockchain. I don't need to explain to you, you are working on it. But that's what's going to be the next stage. And then after this stage is going to be the autonomous entities. Autonomous entities. Any questions? So we are in this stage at this moment. Oops. Okay. So we are at this moment here. The customer era 2010, and we are about 2018. We are here. Internet of Things, big data, and exponential artificial intelligence. And something that it's good to consider when you are working in startups. The first generation of adults that grew up with IoT and AI they are born now. So imagine what these people, the kids that are born now, they are going to be very different than us and you, all of us. Okay, so you need to consider this. If we are in the customer era, you need to consider how the customers 10 years from now, or even 5 years from now, they are going to think. Right? Okay, so we move on. The Moore's law, who doesn't know this? Okay, who knows it? Okay, so that means some people do not. So, everything related to integrated circuits or information technology, the power is doubling every year or every 18 months. That means with 10 times doubling, you talk about 1,000 times more, okay? And with 20 times doubling, you talk about 1,000,000 times more, okay? So, we human beings, we think linear. We say, I will try to be 10% better, 20% better, 30% better. But the information technology and everything related to the technology you are using now is growing exponentially, right? So if you keep on thinking linearly, and your competitors are thinking exponentially, you are dead duck, to put it in mild terms. I don't think I need to explain to you, but I think it's very, very important to repeat it. So this is the story of linear versus exponential. The human beings are thinking like this, but the technology is growing like that. So when the technology is on the second stage of when the technology is at this stage, any doubling, it's almost vertical. So that means you are doubling in power, or you are doubling in speed, and the people that are thinking linearly, they are left behind to dust. So this is the whole story here of where we enter. When we say we enter the exponential artificial intelligence time, and the IoT is about that, at least as far as concerned me. So this is again what I just said. Everything related to the exponentially growing technologies is becoming or will become more efficient exponentially. So everything here, and I can add more, another 50, everything related to this is growing exponentially. So you need to think also exponentially, because thinking linearly is not going to help you. You're going to fail, very simple. Some examples here of the exponentially growing technology. What is behind robotics, what is behind drones, what is behind artificial intelligence, is all this exponential technology. And something very, very important, especially because many of you are in hardware, just to make an introduction, transformation from product economy to experience economy. Who has experience in that? Who is practicing it? You do? Anybody else? Can you give an example?
I know I said I work for Hacks, but the thing I do for Hacks is industrial design. And the basis of industrial design is actually, it's gone from the past where it was about creating artifacts or products to actually creating experiences, memorable events more than a certain object. And we are at a point where, like for example, my generation of people don't want things, we don't own things, we care more about experiences, we don't want a house, we want to have that fun thing, and I think that is something a lot of industrial designers, including me, is working on. Is that an example?
It's going in the right direction. Industrial design is about different experiences, so yes. But this you can apply almost in everything, right? Don't think about the product, the hardware, but think about what kind of different experiences can this product bring to the customer, right? So, what are the 5 mega trends at this moment? They might be more, right? But I chose the, as far as concerned me, the top 5. The top 5 are the age of urbanization. What is happening in Shenzhen? I don't need to explain. Shenzhen was a village 30 years ago, and suddenly it's almost 15 million. That's the example of urbanization, okay? Second one is challenge of an aging world. We are getting older and we live longer. Many of you are very young and don't think about that, but there's an impact in the world, especially China too. Greater global connections. I mean, what's happening, many of you are coming from different countries and you are here. You enable this connectivity. Climate change. I spoke with Yelena and she's involved in this. And the last one is accelerate technological change, and that's the trend I'm going to talk a bit more the next 10 minutes. So what is happening is in 2025 there will be 1 trillion devices connected to each other. And I assume many of you are already creating this kind of products, right? Hong Kong. Shenzhen is becoming the hardware mecca, and you are contributing to this 2025 1 trillion objects connected and talking to each other, the IoT revolution. The second thing from this presentation, from this picture, is that everything becomes faster and faster. The TV took 13 years to have 15 million watching TV, 15 million customers, and the Facebook took only 1 year. And I don't know what's the next one, it's going to take a few months, okay? Here this picture explains 12 top technologies that are influencing the world. And maybe you can reflect by looking at these 12, which ones you are using. These are the 12 technologies that are considered from some people the most important in the world, and they grow exponentially. So, is there anyone missing that you think that is more important than these 12 and you are using it? There are many companies at this moment that they are creating startups, that they are innovating to be able to mine asteroids. Because there's quite a lot of materials in asteroids.
You can add CRISPR.
Yeah, synthetic biology.
CRISPR. Yes, quantified self, but you can add CRISPR, which is genetic modification.
Yes.
But yeah, it's very good. It's very good.
Okay. So, and here comes the main part of my presentation. What are the impacts and what we can all learn, hopefully you can learn something tonight, is what are the impacts created from this exponential growth of the information-related technologies. By the way, biotechnology nowadays is information technology, right? You are using a lot of computing power to be able to calculate, to create new
Genetic models.
yeah, genetic models, and also in the nanotechnology, same story. It's computing, using computing power, it's information technology. So what are the impacts of this exponentially growing technologies? The first one is dematerialization. I think this you might face it already. I'll give you one example. The more integration of hardware functions happen inside the microprocessors, this is the example. And the examples that I faced myself, I was working in audio business. The audio business disappeared and became only a mobile phone and a speaker, right? And video became the same story. The video business disappeared and became a display only, and the rest is again a smartphone. So, the same with transportation. You don't need to own a car down the road. Books becomes just bits. And the last one is something that we need to consider because most of you are in hardware. Miniaturization of products will have great impact in the environmental sustainability. Which products become, as far as concerned me, I believe for the most of the hardware products, they become smaller and smaller. Am I right?
The computer is getting smaller.
The most of the hardware products become smaller. On average, the hardware products become smaller and smaller. So, and I said this is going to have an impact in the environmental sustainability. That's the positive side. So this is the first impact, dematerialization. That means conversion from atoms to bits. Okay? The second one is demonetization. Demonetization means a market segment is reducing in value because a new business model enables the same output, the same benefit, but in a cheaper way. And so, for example, I don't need to explain that to you, but I will. You know what happened when WeChat has been introduced, and what happened with the telco operators. They lost all their long-term, long-distance calls, right? Which was more than 50% of their business, right? So the question is, these are examples of what happened in many other areas, like iTunes has demonetized record stores, Amazon bookstores, Didi. I know what's happening in China, but the business model of Didi. And this will happen in many more areas. So you need to think also in the areas you are working, what can demonetize what you are doing. The third one is democratization. Okay? What does this mean? The accessibility of different technologies. 20 years ago, to have own technology was costing a lot of money. Nowadays, you have access to many different technologies. And here are a lot of examples, like computing power. You can go to Amazon, you can get it not for free, but it's very, very cheap. Artificial intelligence, crowdsourcing, crowdfunding, education, free communication, and all of you, all of us, with one smartphone, we have more power than the most powerful president had 20 years ago. Think about that, okay? And finally, it individuals have more power through social networks than the brands. Maybe you don't realize that, but that's very, very true. One person can create a positive contribution to the brand or can damage the brand together with their network. Number 4, industry and market boundaries are fading. What does this mean? One simple example, the car market becomes mobility market. Okay? And the most important, and I don't know how many of you realize that, the technologies I showed you before, these 12 technologies, they do not, 20 years ago, most of the technologies, they were specific per industry. Nowadays, most of these technologies you can apply in many industries. So in other words, if you are in consumer electronics and you use one of these 12 technologies, you can make an extension to another industry very easily because you can use the same technology. So I go back, and that's what, in fact, these big boys are doing. Baidu, Apple, Alibaba, Tencent, Amazon, they enter different industries by using exactly the same technologies. The business model can be different, but they use the same technologies. So that's number 4. So number 5, we'll go to number 5. Software is eating the world. I don't want to make it very devastating for you in hardware. It's just a wake-up call. It is not enough only to create hardware. You need to see what is the business model, what extra you can add in the hardware to make it more exciting. We talk about experiences, we talk about services. So you need to think beyond hardware. Okay? So the hardware will not disappear, become smaller and smaller, become more intelligent, but you need to add, you need to augment your value proposition with services, with software, with solutions, with connection to the networks, IoT, and all this. The example of Apple started in entertainment business, and then using these 5 technologies, they expanded entertainment, computing, entertainment, communication, education, financial, and definitely they are entering the car business, the automotive business. Okay? It's already cooking for the last 4 or 5 years. And they have tremendous resources, nothing to do. But and they are using the same technologies. That's why it's very easy to move. But that's what is the paradigm change in the industry at this moment versus what was happening 20 years ago. And that means anybody from any other industry can become your competitors and you don't know. You don't know them and suddenly become the number 1 competitor. And you can do the same. That's the point here, right? You need to think a bit bigger than what you think today. Okay? The 5th impact. You need to think much bigger. So not 10%, 20%, but 10 times, even 100 times. Why not? And you need to think more and more. I mean, how many of you, maybe you still do, how many of you say, do you want this quality or less quality to be able to do it faster? Are you still thinking like that? You're still thinking like that, okay? This is the or. And we are, nowadays, with the current technology we have, you can do everything and. That means you can do faster, cheaper, better, and then, not or. So if you think in or terms, then there are many companies that think in and terms, and they are going to succeed and you are going to fail. Okay? So you need to change your mind. And I'll give you a lot of examples. Okay? So, exponential technologies are not about incremental improvement. It's not about incremental. This is linear thinking. It's about the exponential. So you need to think big. They are about radical and huge improvements in something. Huge. You need to think huge. And the last one is enable better and bigger and faster and cheaper and it is possible with the current technologies. And look at the examples here. The first one is about smartphones. And if somebody disagrees with any of these statements, we can discuss, right? the smartphones are better and cheaper and easier to use than previous phones, and all devices they replace like iPod, camera, navigation system, video recorder. Right or wrong? So you see the end and then. Then the same story with WhatsApp and WeChat. They are cheaper and easier to use and offer more variety of functions than traditional telephones. Right? You see the end and then. Number 3, drones. Drones can be used in applications like agricultural areas or buildings. You send the drone and you can take the pictures much faster and cheaper and better than people they were doing in the past. Number 4, automotive. Autonomous vehicles in the future. This is future. It will be easier than the taxis. And the last one is upcoming supermarkets or coffee shops. And you start to have it already in China. There are a few companies, I don't remember the names, excuse me for that. But you can have a better experience without cashiers. And yeah, again, and easier, and faster, and. Yeah? I think you know the HEMA. HEMA is called the supermarket. From Alibaba. That's the story of the supermarket. So number 5, and the number 6 is something you know very well. You need, if you want to succeed, you need to be more open-minded and use resources that are available in the whole crowd and communities around you. I'm pretty sure I can do that, but I would like to repeat because one of the top 6 impacts that this exponential technology bring to you, right? So you need to think beyond you, yourself, and your team. You cannot innovate with your own resources only. You need to use, I call it community resources, crowd resources. That's the only way to succeed, okay? And I think I'm coming to the last thing of my part. So, I have a few questions here. Some of them do not apply for startups, but might be the case they do. The first one is, where are you or your company thinking linearly? We just found out that maybe some of you still thinking linearly, 10%, 20%, 10% improvement. That's not good enough. When your competition is thinking 10 times, 5 times, 3 times, 2 times. The second one is, what exponential technologies can you use to create a competitive advantage? I think you are doing that, so this for startups doesn't apply. But many established companies, they don't use. Number 3, which products or services are going to dematerialize or demonetize first in your industry? You might create a product now, and next year the product is obsolete. Did you ever think about it? Right? That's the message here. Oops. Sorry. And number 4, which exponential technologies are going to disrupt your business? Similar to this. Last one is, what will become free in your industry in the future? What will become free? I mean, you are doing hardware. I think the hardware is the first candidate might be to become free because you're still gonna sell the hardware, but then you are gonna get the money back from services, software as a service, right? So you need to think in broader, okay? Recently I wrote a book. I did not come here just to sell the book. I just enjoy talking and getting feedback. So I wrote a book 2 months ago. It's about exponential growth. So if somebody is interested, the book is in Amazon. I have some copies with me here. I could give it for free, but I don't do that because whenever you give something for free, people do not read. Okay? So if you want to have the book, it's 100 RMB, and you can have it and you can enjoy it. It's about all this principle, which I explained to you today, but also explains how to scale faster your company, step by step, for many different business models. Okay? So that's my part. I would like to introduce Angelo to continue. I assume that Tuli questions answer that later, or
No problem. Yeah. Relax. However, it's fine.
You do it at the end? Yeah.
Okay, part 2. Angelo Traas here. Again, thanks for coming. I'm going to take you on a little journey, the journey of productization and how to ramp up your new hardware product in a successful way. I will distinguish 4 different steps in the phases in the productization process. You see them there: product design, prototyping, the pilot run, and mass production. So this is a little bit old school, just hardware, and I'll try to give you my 10 cents of my experience over the past X years. I will highlight the different trends we see and how they impact the different productization phases. The objective of industrialization or productization is, of course, to be on time, to satisfy the requirements critical to market, critical to quality and critical to customer, as we all know, and we all try to make a decent profit as we go the way. And then linking back to what Mike said before, if you do it the right way, taking advantage of the new trends and take into account some experience from the past, then you can do it and faster and with higher quality and also offer better value to your customer. And just a few words about myself. I have been in the hardware business since '86, so it's quite a long time. About 20 years with Philips Electronics, and then a handful of years with Flextronics here in China and also in Europe. And I worked on a couple of startups in wireless charging and also LED displays. On the way, of course, I made, together with my team, many mistakes, and both in R&D and in industrialization and in production. And I would like to share tonight a couple of mistakes we made, and hope that you will be able to prevent from making them again. All right, then I go to the next one. Yes. So I have 4 more slides, 4 phases in the product creation process, or productization. In the product design phase, the first part, we probably all know, there are the tools. This is the, yes. So you have design tools, computer-aided design, computer-aided engineering, and nowadays you see more and more VR tools popping up, all with the purpose to shorten the design time and the need for less prototypes. You can do more in terms of software evaluation. Pretty standard are the mechanical evaluations in terms of deformation, stress, thermal analysis. That is quite standard. The tools are becoming more and more easy to use. They shorten the design time. You see the VR tools in architecture, environment popping up, and also in the car design, car styling. I've seen some pretty cool VR tools. So that is fantastic to reduce the need for prototypes, which are of course very expensive, and to save costs. So I can only say use those tools, but then again, just with those tools, you won't get there. There's also some old school kind of experience things that you have to take into account. There, I'd like to highlight design for supply chain. So what does that mean? Who are your suppliers? What is the lead time of your components? I remember in my wireless charging team, at one time we had an MCU designed in with a lead time of 13 weeks, and all the rest of the bill of material was below 6 or 7 weeks in time. So in terms of supply chain, having such a tremendous long lead time item is a disaster. So fortunately, we caught it quite early in the process, managed to change to a standard MCU which had a 6 weeks lead time, and we saved ourselves a hell of a lot of trouble with ordering long lead items and stuff like that. Second point I'd like to highlight is you need to design in a control point. Okay? What is a control point? That is like a component or subassembly that you have complete control over. You have the IP and also the availability. Again, in my wireless charging startup, we had our own ASIC, application-specific IC, with all the design intelligence of the PhD guys were baked into the ASIC. The software was in there, There was a unique, very elegant control point, and nobody could actually copy our products because it was simply not available. Nobody could order that. Now, it doesn't mean that you have. Sorry, I should use the microphone. Right? Sorry. Hey, nobody said it. I don't need to shout so much. Then again, there's also such a thing as, especially in China, reverse engineering, so people can figure out what your ASIC can do. So there is a way to re-engineer that. So, but it increases your head start. It makes it a little bit more difficult for the competition to catch up with you. The next thing is decide where to allocate your production. Where to allocate your production, yeah, that is key. Do you put everything in one hand? Do you work with one supplier? Or do you take your key components, you source them separately, and you work with one assembly center? You also need to think about, is there an alternative for your case, your market? Is there an alternative to China? China is very comfortable still to do it, maybe not the cheapest anymore, but the supply base is fantastic. A friend of mine is running his assembly operation now from Romania. He still gets some stuff from China, simply because the supply base is much more mature, but he takes advantage of the lower labor costs in Eastern Europe. It's about a factor 2. Yeah? Yeah. So where to allocate your production, pretty obvious. Another one, don't forget to think together with your customer about the delivery terms. Do you do FOB Hong Kong, free on board, or do you do, for example, delivery duty paid USA? You may not be familiar with the details, but maybe you want to talk to some logistics people. We did a project with a search company in Mountain View, California. I forgot the name. They want us to be, they wanted the products, the wireless chargers, delivery duty paid USA. And we almost signed that, but then what does it actually mean? You become importer of record. I see a lot of people saying that this is good, you're smarter than me. So, fortunately, we realized as a tiny startup company, we would take tremendous risk and liability, assuming that importer of record responsibility. So, we actually said, sorry, Mr. G, we can't do that. And they actually accepted them to take our products FOB Hong Kong. So, even as a small guy, you have to watch the risks for your company. Yeah? Then, after taking all that in mind, there's still some surprises you can have in this design phase. Some key components may still have long lead time. My experience is, you have to live with it, then buy them, but be careful, do it yourself, and base it on a forecast from your customers. Yeah. Anyway, it's a story by itself. Another thing in this time of the project is, as a startup, you have limited leverage with your suppliers. So how do you deal with that? So therefore, it's very, very important in the early stage to think through: are you aligned with your supplier partner? Do you have the same ideas about initial volumes, business, margins, etc.? So there you may want to talk to some experienced people about the ins and outs. Where do you want to start? You go with a tier 1 supplier like Flextronics or Foxconn, or do you go with a tier 3 or whatever? Time for the next one. Next phase, prototyping phase. Let me try from this side. So there, clearly the trend is the use of 3D printing for rapid prototyping. Oops, sorry, wrong button. 3D printing nowadays, I think most of you guys are familiar with it. Not only in plastic, but also aluminum and steel. You have the facilities available. Make use of it. It will, of course, have a lot of advantages. Then it brings you faster to market, less waste, and more cost effective. For sample making, I have a couple of things. Yeah. In my experience, it's important to think through what kind of samples do you want to make. There are mechanical samples, electrical samples, but also commercial samples. They don't all have the same requirements. Typically, commercial samples need to look perfect for the photo shoot and for your customer. Electrical samples, actually the mechanics around it doesn't really matter. So you can use different and maybe cheaper methods to make those samples. If you make 3D printing, or if you make perfect painting for your product, that only need to be for the commercial sample. Mechanical samples, don't forget the gift box, the packaging, it's actually part of your product. And then typically the mechanical sample is used for drop tests and thermal tests and stuff like that. Other things not to forget, of course, your labels, they're part of your product. And if you go to do serious volume, you also need to cover the traceability, right? Which part are in which product and shipped to where. Environmental requirements, yeah, it's a big thing.
But how do you do traceability? Like, can you talk a little more about that?
Yeah, traceability. The simplest I have done is basically you highlight a couple of key components, for example your ICs, you scan per batch of ICs or transformer, basically the product code, and that is then logged into your shop floor control system. So that's logged into the PCBA code number, and that PCBA goes then into your final product code number. So then later in the field, if your product XYZ has a problem, you know exactly which IC was it, which transformer, and which PCB. So you can hit somebody on the head and say, hey, you didn't solder that properly. Yeah. And that's typically something that you can already, with your supplier partner, align up front. I had it after a while in my standard contract. So hey, we need to cover traceability, because if you're going to ship to tier 1 customers, that's on their list. If you can't show them where the products go and what is inside. Okay? Regulatory requirements. I'm not going to say much about that. Environmental. Yeah. Also there, make sure to get the right people in the loop there. Because there's a big difference between ROHS, for example, ROHS, halogen-free, and there's also REACH. So REACH for Europe is not trivial. There's a hell of a lot of paperwork there. And there's a lot of people in China or suppliers that say, yeah, I can do it, no problem. But then you end up that you get contracts that are signed, but actually there's nothing behind the contracts. There's actually nothing happened. And you get in trouble then with your customer. So there's a point of attention.
May I ask about
Sure.
environmental requirements? If you compare Europe
Yes.
to the US, I guess Europe is more stricter in terms of environmental requirements.
Europe is more strict, yes. Yes. Yeah, as far as, I didn't check the last 6 months, but Europe needs REACH. And that involves quite a lot of paperwork, and for US, ROHS is still good enough, as long as it has FCC and that kind of
additional reach.
Yes, yeah.
Actually, US has become easier recently.
Okay, yeah.
Thanks to someone, US has actually become easier than it used to be.
Yeah, with Mr.
Mr. T.
Makes sense, right?
Okay. Yeah. Yeah, one more thing I wanted to mention is on the last one. In my experience, I always had surprises on the product pricing. So what I can advise there, what I used to do is typically in the beginning of the project, take a line item in your costing. First of all, do the costing yourself. Yeah, it's called unforeseen. Now that doesn't sound very intelligent, but actually it is a good solution. And in the beginning of your project, it can be a few percent of the bill of material. And as the project goes along, you should be able to reduce that. And at the time you go into mass production, it should be zero, the unforeseen. Otherwise you're doing something wrong. Yeah. Anyway, I made a couple of mistakes by getting the wrong pricing. Typically what goes wrong there is the supplier quotes you a price and then oops, it was only ex-factory price. Yeah, okay, so how to get it from the ex-factory to your factory. So there's some transportation cost not included in the price. And if you have that for a couple of items, then you get screwed.
Do currency fluctuations affect that? Like you worry about that?
Not that much trouble with that, actually. Yeah. If you work very fast, it doesn't matter.
Hey, so sorry, one question. Actually, again, talking about Mr. T, right? Like another unforeseen recently is the tariffs, right? A lot of the startups I work with recently are having a super hard time because they're constantly like increasing tariffs and I like the advice that you gave that unforeseen should always be reducing, but in this case it's actually increasing by such a massive amount sometimes that some of them are having like existential issues.
And that reminds me that I remember putting in my contract, if for some reason there's more than a 10% deviation, you're able to start renegotiating on the cost. That's another one you can do. Same with currency, by the way. So if it's like an unforeseen jump in whatever pricing, so always try to put in some disclaimers like, So the legal part is indeed also important. The next one. Yeah, then we go into I call it the pilot run phase, the design verification. There we see on the production line more and more, let's say, IoT devices popping up. The smart products need smarter and smarter manufacturing environment to get it right. You need process control. You can measure most things.
What? All right, no problem.
It's redundant. Okay, sorry. I think the main message here is, like already for 20 years in China, this stuff is being measured, but it was never, let's say, connected to some sort of system that when the screw torque or the weight is not as it's supposed to be, that the line basically stops. It becomes like a foolproof. That is the new thing. So you are actually able to get more stable quality control. In the old days, you and to some extent still now, you're dependent on the operator for controlling the quality. Yeah? So now it is actually controlled by the IoT system around the line. Okay, so what can still then happen? After using still these new tools, in the production line, with the smarter line, what do you still need to take into account? Highly advisable to build a small pilot quantity for stress testing. Typically for wireless chargers, we used to build 40 to 50 units. For big LED displays, those are expensive parts. We used to build 1 or 2 and put them in stress test. Yeah. And I'll go a little bit quick through this slide. Just want to share one story. It's related to the accelerated life test. One time we were making audio systems with a CD changer. So a 7-disc CD changer. This was Philips Singapore. And you won't believe it. So I had to build my 40 units. And we're doing the accelerated life test, so we're running 40 units in 40 degrees centigrade ambient. And it was like 10% of the units would go in hang up after 10 hours. Okay.
So you can imagine I was project manager, and during the weekend, this stuff always happens during the weekend somehow. So I had an engineer over from Vienna. He was the R&D guy, and he said, "Angelo, we have a problem." And I said, "Where are you?" "Yeah, I'm in the accelerated life test room." So it's like 40 degrees there, and he was pointing to me like, "Okay, these are the 10 units that actually dropped out, or less than 10, so 4." Anyway, to cut a long story short, we did not manage to find the root cause. It must have been some timing issue in the 7-disk changer related to the main computer thing in the mini system. So what we ended up doing is add one line of code, so telling to the pickup unit in the CD changer, if you lose your track, try again. If you lose it again, try again, and try 10 times. That solved the problem. So then we could actually ship. But can you imagine what disaster it would have been in the market? So we managed to prevent that. So I'm a strong advocate of, it will cost a little bit of money, but do your stress test, and you need some statistical relevant data. So do a stress test on 1 unit is not very helpful. Do it on 10, 20, 30 units. Anyway, any good quality guy can calculate for you how many you need to put in test. Okay, and go to the last slide. After your pilot, then hopefully finally you can go into mass production. Related to the mass production phase, I see this trend globally. I call it here the Industrial Revolution. It's Industry 4.0 or Made in China 2025. Those are two campaigns that actually exist. You probably heard about the China campaign. What they're trying to do is actually fundamentally improve their industrial capabilities in China. Yeah, they want to move up the food chain from high labor intensive to much more innovative and higher automation in the production line. And there I put some characteristics of, you talk about computerized maintenance, higher uptime, and also augmented reality that is then used to instruct the machines and to do the maintenance. And here you see it actually happening, using augmented reality to train a robot and to do maintenance. So it is actually happening. And we were talking about Mr. T. Mr. T is a little bit frightened about this whole China 2025, so it's quite relevant, I think. What else? Yeah, you need to make sure all your points are closed. If you go into mass production, you need your certificates, and you need resources on the line, because there will always be a lot of things that go wrong. I could talk all night about it. Yeah, these are pretty obvious ones, but they happen. Parts delivered out of cosmetic spec. Always like that. Yeah? During the pilot run, perfect. The first 1,000 for mass production, always 10% is wrong, if you're lucky. Right? So he will push all his rejects to you if you're not careful. No production capacity, because you probably had some delay in the ramp up. And your production slot, your production capacity is probably gone, so be aware of that. The final prices, you'll have surprises, and the suppliers finally realize they have ramp-up curves to make, and they may get in trouble. It happens to big companies. When I was in Flextronics, we were building a microphone accessory for Microsoft, actually, in Zhuhai. And this little top of the microphone was a metal part, so it was a third-tier supply, could not manage the ramp-up. It was a pretty crazy ramp-up for Microsoft in Flextronics, but so we had at some point in time in Zhuhai from Microsoft, all sorts of top managers sitting on top of us, and then a couple of top managers from Flextronics, so it's pretty hot at that time. All right, to wrap up, my personal view is that for China is still, I think, short term, the ideal place to make hardware. China is getting expensive, as I already said. Has competition from Vietnam, Cambodia, and also Laos. But I think short term it will still be a good place to do your hardware. But because of these two campaigns, China is going to run very fast and try to pass companies like, or countries like US, Japan, and also Germany. So here you need to think exponential in order to be prepared. And that is only going to make life dynamic. And the only constant is that there's change all the time. All right, that's all I have.